The total number of species alive on Earth can, in theory, be counted. In time, we will be able to write the number down within narrow limits, but for the moment, conservation scientists look at a world census as a dilemma wrapped in a paradox. The amount of Earth's biodiversity, we have found, is like a magic well. The more species humanity extinguishes, the more new ones are discovered. But this only adds to any estimate of the magnitude of destruction underway in species per year. We need to apply the approximate extinction rate of known species also to those that are unknown. There is no reason as yet to suppose that the two groups of species, known and still unknown, differ from each other radically. That realization leads to a dilemma that turns out also to be one of the great moral questions of all time. Will we continue to degrade the planet to satisfy our own immediate needs, or will we find a way to halt the mass extinction for the sake of future generations? If we choose the path of destruction, the planet will continue to descend irreversibly into the Anthropocene epoch, the biologically final age in which the planet exists almost exclusively by, for, and of ourselves. I prefer to call this option by another name, the Eremocene, the age of loneliness. The Eremocene is basically the age of people, our domesticated plants and animals, and our croplands all around the world as far as the eye can see. To measure the biosphere and its rate of diminution, the best unit to use by far is the species. Individual ecosystems, which are composed of species, are much more subjective in their boundaries. One thinks of foothill scrubland grading into mountain forests, oxbow lakes into rivers, riverbanks into deltas, and ground-soaking seeps into springs. Genes, which prescribe the defining traits of species, are on the other hand objective and can be exactly defined, but are more difficult to read and use to meet the multiple needs of taxonomy and biology. You can, with binoculars, census a medley of warblers as they fly from one ecosystem to another, say forest edge to forest interior. But identifying their preferred habitat is difficult, and sequencing their DNA for identification is even more so without capturing or killing specimens. Far more important, however, is the circumstance that the traits with which we recognize organisms are the ones that they themselves use, variously by sight, sound, and smell. With species in mind, we are able to understand how life evolves and how and why each life form is unique in its combination of anatomy, physiology, behavior, habitat preference, and every other property by which it survives and reproduces. Biologists define species as populations of individuals that mostly share the same traits and, in addition, interbreed freely among themselves under natural conditions, but not with other species. The textbook case of proven species is provided by the lion and tiger. The two big cats will interbreed when caged together, but not in nature. In ancient times, their geographic ranges overlapped across a broad region, lions through all of Africa, including the Mediterranean coast, then east to India, where a small population still survives in Gujarat, and tigers from the Caucasus to easternmost Siberia. No hybrids have ever been reported among wild populations in either ancient or recent centuries. In 1758, Carl Linnaeus, a professor of botany at the University of Uppsala, published the system of classification that biologists have